Hello and welcome to section 4.1. We're going to be working with triangles a lot this chapter. And our first property that we're going to learn about is the triangle sum theorem. There's some review stuff with classifying triangles by the angles and their side lengths. That should be reviewed, and you guys may have seen this. I'll go over this part in class, this top part. Ignore that part there. This is what you guys need to jot down here, though. Triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180. I'm going to be proving this in a little bit here. So for the time being, just write that down in your notes. You guys may have seen that before or may know that. And then we haven't talked about corollaries yet. They're statements that can be proved easily using a theorem. So this is the corollary to the triangle sum, and the reason why this is easy to prove is we know that a plus b plus c equals 180, and we know that c equals 90, so really you have a plus b plus 90 equals 180, and then you can subtract 90 and you have your theorem. So this is just basically, it's a theorem, but it's extremely easy to use based off of a theorem we just learned about. So they call it a corollary. Alright, so here's this proof. This is a really, really odd proof. And the reason why it's an odd proof is because we have to construct an auxiliary line. And this is the parallel line postulate. We talked about it. I mentioned in one of my previous videos. Basically it says if you have a point that's not on a line, so we're dealing with line AC, and point B is not on line AC, there's one line that's parallel to AC that goes through B. And so it's just, it's kind of an odd first step. So construct line L, we'll call it L, parallel to AC. We'll call this line L here. And this is the parallel line postulate. And this is not something that I wouldn't expect students to pick up on their own. But now that you know it, hopefully it makes sense. And then that creates two new angles. I'm going to call them angles 4 and 5. So what I want to do is I want to show that 1 plus 2 plus 3 equals 180. Well, I know that 4 and 2 and 5 add up to 180. So I'm going to say that 4 plus, and I should be really technically, I should say the measure of angle 4, dot, dot, dot. But I'm just going to go 4 plus 2 plus 5 equals 180. And it's a combination of angle addition with linear pair postulate. So I'm going to shortcut this a little bit. What I technically have to do, I technically have to say that 4 and 2 add up to an angle. I'd say like 4 and 2 add up to 6. And then I'd say that 6 and 5 are my linear pair. But I'm not going to get into that for the sake of this proof because it's just a lot of extra work that I don't want to confuse you guys on. So 4 plus 2 plus 5 add up to 180. Now 1 and 4, since we know that the lines are parallel, 1 and 4 are alternate interior angles, so they're equal. Same with 3 and 5. 3 and 5 are alternate interior angles, so they're equal. So I say angle 1 is congruent to angle 4, and 3 is congruent to 5. And they're alternate interior angles. And then technically I have to say that the measure of angle 1 equals the measure of angle 4, the measure of angle 3 equals the measure of angle 5. Definition of congruency. Okay, I just want to explain quickly, if I didn't explain before, a little bit about what I was doing here with this proof. When I said the measure of angle 4, I should have been specific and put those into the proof. The measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. That will explain why I had to do this step here, because I'm going to make a substitution. 4 is going to become a 1, and then the 2 is going to stay the 2, and then the 5 is going to become the 3. So I'm doing a double substitution here. And this finishes my proof. Okay, so what I just did is I showed that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. The tiled staircase shown forms a right triangle. The measure of one acute angle in the triangle is twice the measure of the other. Find the measure of each angle. So we're going to use the triangle sum here, theorem right now. So here's our picture that they give us. And this is a 90-degree angle. It says right triangle. And the measure of one is twice the other. So we'll call that x and 2x. So 3x, if this equals 90, the other two have to add up to 90 as well. So divide by 3, and x equals 30. Find my measure of each. So this one would be 30 degrees, and then this would be 60, and then of course you have 90 there. Interior angles versus exterior angles. The angles on the inside are the interior, and then if you extend any of the side lengths, it creates an exterior angle. So for example, if this is my triangle and I extend this angle, this right here would be the exterior angle. So if you need to jot that in your notebook, those notes there. And then I can talk about that in class, but what you guys need to write down in your notes is the exterior angles theorem. And I'm going to explain this. It says that the sum of the remote interior angles. It probably doesn't actually use the terminology remote interior. However, these two here called remote interior, or that's one vocab word for them, is equal to the exterior angle. So A plus B equals 1. And the proof is actually really easy. Well, sort of. It's a fun proof. That'll be in your homework tonight. So if I know that this is 2x and this is, say, 3x plus 5, and this is, say, 110, you can do 2x plus 3x plus 5 equals 110, and then you can solve that equation for x. This is the problem I just made up, just like the one I just kind of showed on the board. So if I take these two remote interior angles and I add them up, it equals this exterior angle right here. And then you can solve that for x. So x equals 75. JKM, I should actually plug that back in because it's looking for that one there. So it'd be 150 minus 5 is 145. And this should be a review for you guys, hopefully. All of these things, scalene, no sides the same, isosceles 2, equilateral 3. And then classifying triangles by angles, acute, 3 acute angles, right, 190-degree angle, obtuse, 1 obtuse angle, and equiangular, all 3 angles are 60 degrees or the same. So make sure you guys know how to classify by sides and classify by angles. That should be a review for you guys. I'm going to do this question with you guys in class. It involves the distance formula and perpendicular lines. So we'll save that for class. And then there is your assignment. Thank you guys for tuning in to the first section of Chapter 4.